How to prevent overfitting in soccer prediction models. Imagine trying to predict the outcome of a soccer match and having your model get too attached to past results, making it less accurate for future games. That's what overfitting does. It makes your model too specific to the data it learned from. When a model overfits, it captures noise or random fluctuations instead of the real patterns that matter. This means it might perform well on past data but poorly on new matches, which is a big problem for anyone relying on these predictions. To keep your soccer prediction models reliable, you need to use some smart strategies. First, always test your model with validation techniques like k-fold cross-validation. This method splits your data into parts, trains on some, tests on others, and repeats. It helps you see if your model performs consistently across different data slices. Walk-forward testing is especially useful for soccer because it respects the order of matches. It trains on earlier games and tests on later ones, mimicking real-world prediction scenarios. Next, keep your model simple. Avoid adding too many features or parameters that might fit the training data perfectly but fail on new data. Use techniques like principal component analysis or select only the most important features to reduce complexity. Combining multiple models through ensemble learning is another good move. For example, mixing predictions from random forests, gradient boosting machines, and neural networks can balance out their individual biases and variances. Be careful about data leakage, which happens when information from the test data sneaks into the training process. For example, don't use future match results or derived variables that include future data during training. Always perform feature selection within the validation process to keep it unbiased. Use high-quality data from trusted sources like official match statistics, player performance metrics, and advanced stats such as expected goals. Combining data from different sources helps avoid overfitting to peculiarities in one dataset. Regularization techniques like L1 or L2 penalties add constraints during model training, discouraging the model from fitting noise. Lastly, keep a separate evaluation set in touch during development. This final set acts as a true test to see how well your model generalizes to unseen matches. When building soccer match outcome prediction models, combining historical data, player stats, and advanced metrics is common. Applying these strategies ensures your model learns real patterns, not just memorizes past results. For example, validating an ensemble model with walk-forward testing on Premier League data can give you more trustworthy predictions for upcoming fixtures. Remember, preventing overfitting means making your model more reliable and better at predicting future matches based on past trends. Using proper validation, simplifying your model, avoiding data leaks, and relying on diverse, high-quality data all help your soccer prediction models stay accurate and useful.